Okay, today we are adding and subtracting fractions with like denominators. So just like you did back in 5th grade, remember what happened if I had 1/2 and 3/2? What do we do? 1/2 plus 3/2. Who remembers what we do when we add with like denominators? Go, Max. We add the numerators only. When the denominators are the same, they just say the same, and so it becomes 4 over 2, and that reduces to 2. Okay? Same lesson. To add and subtract algebraic functions. Okay, so I want you not working horizontally. Let's fix this right away. I don't want you to do, if you ever see my PowerPoint, these easy ones you can do it, but as we get bigger, they need to be in steps. But I don't want you ever doing it horizontally because it creates a bunch of bad math. We call it run on. So when I have x over 10 plus 3x over 10, can't we say that that's x plus 3x all over 10? And then that we simplify the numerator, and what does that become? 4x over 10. And the last step we do is reduce. 2 goes into that twice and into that 5 times. So it's 2x over 5. Okay? Questions? Okay, next. Now notice, you cannot simplify here. Let's say this was a 2. You cannot simplify here. You have to add the fractions together and simplify afterwards. If you reduce it before you've simplified, it will be wrong. Okay, so you reduce last. Okay, the next one, why don't you try number 2? Thumbs up when you're done. Okay, so Julia, what do I get in the numerator? Good. Over, all over the same, okay? And then what does it simplify to? Perfect. Okay? Is there any simplifying to do? Nope. Moving on. Okay, 4m over 5 minus 2m plus 1 over 5. So we're going to put it all over the same denominator of 5. And now, when I have that negative is subtracting the whole fraction, the whole numerator. So I'm doing 4m, and then I have minus that whole quantity of 2m plus 1. I'm probably doing one extra step. If I were doing this on my own, I would probably distribute in the next step instead of doing 2 steps, but I'm just trying to show you. So it becomes 4m. Are you with me? Now what? Somebody? Go. Minus 2m minus 1 all over 5. And then we simplify in the numerator. I have 2 like terms. So that becomes 2m minus 1 all over 5. Is there any cross canceling? Nope. Okay, can I move on? Okay, you guys try the next one. See, I don't like you doing this because we're not really going to be doing this. I'm building you up for equations. Okay, pause the recording and you do. Why don't you try 1 and 2? So, on the first one, we're going to get 5n plus 7 all over n plus 3. Is there anything to reduce? No. On the next one, we're going to get y squared minus 4y all over y minus 4. I have a bunch of people trying to make this a difference of squares. Is it?
No.
No, because the y is not squared. If the y were squared, it would be a difference of squares. Because y is a perfect square, 4 is a perfect square, but this last y is not. So, what kind of factoring do we do? It is factorable because they have something in common. What kind of factoring, Brianne? Greatest common factor. What's the greatest common factor? Oh, and then I saw somebody cross-canceling this way. Can I do that? Why? Can't take a piece of a binomial. It's like taking a piece of my arm. So what is this factor to, Brianne? Good. All over y minus 4. Okay, questions? What? Can I? Why can't I? Do the binomials look exactly the same? They can be cross-canceled, and so what's left is just y. Okay? Just because the only reason I'm using the parentheses is to show multiplication with the y. There's nothing next to the one and below, so I don't need to write the parentheses, but it's still a binomial. Okay, everybody understanding that part? Yay or nay?
Yay.
Okay, 2 more. You want to try this one? Go. Pause the recording. Okay, the new numerator is going to be x squared minus x plus 20 all over x squared plus 2x minus 35. Did anybody make any mistakes at this level? Because this is subtracting the entire fraction. You have to. In that second step, she said she didn't put parentheses. But that negative has to be distributed to the whole numerator. So that means it's going to be minus x minus 20. Did everybody get that? X squared minus x minus 20 over x squared plus 2x minus 35. So we'll factor the first one, what multiplies to negative 20 and adds to negative 1. What? Negative 5 and 4. So then it's x plus 4 times x minus 5. And then on the bottom one, we're going to do what multiplies to negative 35 and adds to positive 2. Oh, well, not in the beginning. In the end, yes, you have to factor it. You factor everything. It's 7 and 5. Which one's positive? Which one's negative? Okay, and so this is all going to be over x plus 7 times x minus 5. Now we cross cancel and we are left with x plus 4 over x plus 7. So the question is, she said that I did not say, I said not to do anything to the denominator. Meaning I didn't want you to add those denominators together at this point right here. Right here. But you have to factor all parts, otherwise you can't reduce it once you combine the two fractions together. Once you distribute that negative, you have combined the two fractions together, right? Once you get that combined numerator, you have to factor it, factor the denominator, and then we cross-cancel. Last step is cross-canceling. Everybody clear? And my final answer is this. Did anybody not distribute the negative to everything? Okay, let's try the next one. Okay, why don't you pause the recording and try the next one on your own. All right, let's check our work. So the first one's x squared minus 9 over 2x squared minus 6x. The numerator becomes the difference of squares. We factor it like that. And the denominator, we factor a GCF. And then we can cross cancel, and we are left with x plus 3 over 2x. Sorry, guys. Okay, let's try the next ones. Go. All right, let's check our work. So, first one, we have 3x minus 3 over x squared minus x. They're factoring the x squared minus x right away. We can put 3x minus 3 all over the same denominator, x times the quantity of x minus 1, and then we can factor our numerator. And now we can cross cancel our x minus 1s, and we are left with 3 over x. On the next one, it's a similar one, 2x plus 2. And I've got all over x squared minus 1. So I can put 2x over 2 all over those difference of squares, which are all factored, x plus 1, x minus 1. And then factor the numerator. And now we can cross cancel our x plus 1s. And we're left with 2 over x minus 1. Questions? Okay, last question. You want to try this one? Yes. Pause it. Next one, 2x squared minus the quantity of 2x plus 40. Did we distribute all the way in? No. Okay, x minus 5. So that's 2x squared minus 2x minus 40 all over x plus 4 times x minus 5. Then I go to, what? No, it's a GCF. You forget the first step. You got to get there. GCF, 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 GCF. Okay, GCF is 2 times the quantity of x squared minus x minus 20 all over x plus 4 times x minus 5. Okay, what multiplies to negative 20 and adds to negative 1? How about negative 5 and positive 4? So I'm doing this like this because I'm out of room. And I get 2 times x plus 4 times x minus 5. And that means I'm x plus 4, x minus 5. How many people got this final answer? Oh. Wait, did I get it right? Yeah, it's 2. Did you guys get 2?
Yep.
Okay, where'd you go wrong? Shh.
I just didn't do the GCF. I went straight to lead coefficient.
Lead coefficient, yeah, because what's going to happen is you're going to lose your 2 if you don't pull it out. All right, and that is the lesson for today.